on the back, we're going to talk real briefly about angle of depression and angle of elevation, just so that you're familiar with it. We go to Cedar Point. We have this roller coaster ride, and we talk about angle of depression. It's measured from the horizontal down to a line of sight. So up here at the top, we have Haley. She's riding a roller coaster, and she's looking at her friends down here at the bottom of the roller coaster, waiting for her at the end, right?
Oh my gosh.
Haley has long, dark hair. Okay. So, we've got up here at the top of the roller coaster, okay? And we want to know, what's this distance? I know this is a curved distance, but if I make a triangle here, we'll be rough, approximately close. What is this distance to the finish line if we're on, like on the roller coaster? Okay, that's x. Okay, so we want to do a few things. The first thing we need to do, I'm already telling you, we need to start at the angle. We always start at the angle. From there, what do? Yeah, we label the sides of the triangle. So if I'm here, and here's the right angle, this is our hypotenuse, and this is the side opposite. So we labeled our sides. Now what? We need to decide which ratio to use. Do we use so, ka, or toa? I have opposite, and I have hypotenuse. Which one is opposite and hypotenuse? Deal with. So, your sine, right? So then we're going to substitute, and then we're going to solve. This is like 1, 2, 3, and 4 is what that was. That cut off. So if we use sine, we say, well, sine of our angle, sine 44, equals, sine is opposite, which is 100, over hypotenuse, which is x. X is down in the denominator, so we are going to divide. Switch out whole thing and divide. 100 divided by sine 44. Type it in your calculator just like you see it. And we get, if we round it to the whole number, 144 feet. So we get x is 144 feet. Over here. If we talk about angle of elevation, that means we're looking up. It's an angle from the horizontal, so if we look horizontally and we're looking up to a line of sight, we stand here at our angle. We label our sides. I want to solve for x first. This is the side opposite, and this is our hypotenuse. Opposite and hypotenuse deals with sine. Sine of your angle equals the opposite over the hypotenuse. X is up high, so we multiply. Go times 20 here. Type 20 times sine 35 in your calculator, and you get x is 11.5, so this is like 11.5 feet. But how about this? Can we also find this side? I might call this y just to show that it's different. If I'm still at my angle, this is the adjacent. And here's the thing. I could use the adjacent and the opposite, but here's my only drawback. If I made a mistake when I found this answer is going to be wrong too. So I would say, let's look at this one. Let's look at the information they gave us. Adjacent and hypotenuse, that is your ka. There's your ka. Cosine 35 equals adjacent over hypotenuse. Y is up high, so I multiply, and y equals 16.4 feet. So if I put it on my picture, I'm like, does this make sense? This is 16.4, 11.5, and then 20 for my hypotenuse. It's the longest side, probably. Let's jump, let's do 7.7 yet. if we solve right triangles, 7.7 just takes it all and pulls it all together for us right now. Okay? It's nothing new. We just need to do a couple steps in one. Solving right triangles, this means we find the measures of all sides and all angles. Find the measures of all sides and all angles. So how do we find sides? At the start of chapter 7, if you knew two sides, how do we find the third? We use the Pythagorean theorem. What's Pythagorean theorem say? A squared plus B squared equals C squared. So we can do that now. We can go back, we can do Pythagorean theorem. Lately, we've been doing a lot of trig. We've either used sine, cosine, or tangent. In chapter 6, we had two triangles and we used proportions. We compared your corresponding sides, we used proportions. And we also have our special triangles, where we used our 30, 60, 90, and your 45, 45, and 90 rules. Those are quick shortcuts. You don't ever have to use those if you don't want to, because you can always use your trig or your Pythagorean theorem. But that's another shortcut you could use. To find angles, lately we've been doing the trig and using the inverse. We've used sine inverse, cosine inverse, and tangent inverse. And how else can we find angles? How many degrees in a triangle? 180, so we can go 180 minus measure of angle A minus measure of angle B, or whatever those two angles are. Add them and subtract from 180. Two different ways to find angles. So check this out. If I say solve the right triangle, I need to know all my sides. Do I know all my sides yet? No, I have two that are missing, and I need to find my angles. I've got one angle that's missing. So let's start here. If I say find side BC, I'm going to call it maybe X. Start at the angle that we're given, just not the 90 degrees, and label. This is opposite, and this is hypotenuse. Opposite and hypotenuse, that deals with sine. So we say sine of our angle equals the opposite over the hypotenuse. X is up high, so we multiply. 40 times sine of 23 will give us X, and X is 15.6. So this side right here is 15.6 feet. Thanks. So now I have two sides. How could I find the third? Could we do Pythagorean theorem? A squared plus B squared equals C squared? Yeah, we could. To me, that takes a little bit of work. I'd prefer to do this. But you can do it however you want. I'm going to call this one Y. And based on angle A, this is the side adjacent. I just think this is a little quicker. I have adjacent and hypotenuse. So that tells me to use cosine. So I say cosine of 23 equals my adjacent over my hypotenuse. Y is up high, so we multiply. 40 times the cosine of 23 will give us Y. And if you do that math, we get 36.8 feet. So this side is 36.8 feet. And I just look real quick, I'm like, does this make sense? This is 15.6, 36.8. My hypotenuse is 40, it's the longest side, so probably. And then to find angle B, how do I find this third angle?
Why is that? Like,
Yeah. 90 and 23 gives us 113. That's the easiest route. And 180 minus 113 gives us 67 degrees for your other angle. Cool. So I can put that in my picture. This is 67 degrees. So this is just kind of a check for us to clean it all up. What are my sides? I have 40, I have 15.6, and I have 36.8 feet. I have 3 sides. I know all 3 sides, so that's just like, okay, our sides are good. How about the angles? We have 23 degrees, we have 90 degrees, and we just found the other one is 67 degrees. All 3 sides, all 3 angles, we solved it. There's nothing else you could find on that triangle. You could find the area, you could find perimeter, but we know everything about that triangle now. Example 2, we're up here. Solve a right triangle that has a 50-degree angle and a 15-inch hypotenuse. What do we do first? Yeah. First, we draw a picture. If you don't have a picture, draw one. Solve a right triangle. What do we have? A right triangle. So it has to have a right angle in it. Right triangle. We have a 50-degree angle. I don't care where you put it as long as you get it in there. 50-degree angle. And our hypotenuse is 15 inches. So here's my hypotenuse, 15 inches. Yep. Go quick. Shh, just go. Number 2. Find the missing sides. Don't even take a patch, just go. To find the missing sides, I have 2 missing sides. Let's call one of them X, call the other one Y. We always start at your angle. Label what you have. Opposite, here's the hypotenuse, and this one would be adjacent to us, next to us. Deal with one of them first. So I'm going to cover up this Y, and if I have opposite and hypotenuse, that tells us use sine. Sine of 50 equals opposite over hypotenuse. X is up high, so we multiply 15 times the sine of 50, and X is 11.5 inches. So I can put 11.5 on my picture. Now I have 2 sides. If you wanted to, you could go a squared plus b squared equals c squared and solve for that side. To me, that's a little bit of work. I'd prefer to do this. If I now have y and my hypotenuse, the adjacent and hypotenuse, a and h, that's your cosine. Cosine of 50 equals adjacent is y over hypotenuse, which is 15. Y is up high, so we multiply. 15 times cosine 50, y equals 9.6 inches. So this side is 9.6. So I have all 3 sides. Do I have all 3 angles? No. Find your third angle yet. 90 and 50 gives us 140. 180 minus 140 gives us 40 degrees. So you can put it on your triangle if you want. And then just a real quick check. What are the sides? We have 11.5, we have 9.6, and we have 15. And what are our angles? We have 90 degrees, we have 50 degrees. Sorry. We have 90 degrees, we have 50 degrees, and we have 40 degrees. I have 3 sides, I have all 3 angles, I solved it. We know everything about that triangle.